Okay, we just did question 1 from tutorial 8, but admittedly, question 2 is a lot more difficult, so that's really where we should have started. Question 1 was just too fun to pass up. What we're doing in question 2 is using the generating function so that instead of just having the answer for number 9, we can do it for any n and keep reusing that solution. So we want to know the sequence whose nth term is the number of partitions of n into parts equal to 1, 2, or 3. So most people had a good handle on the fact that if you wanted the parts equal to 1, you needed to use the function that looked like this. And for parts equal to 2, you need this one. And for parts equal to 3, you need this one. And because of all the work lately we've done with generating functions, you know that these are 1 over 1 minus x, 1 minus x squared, and 1 minus x3. So in part A, when you're asked for the generating function, that's all you need to put as the answer. Part B, though, asks us to use that to find the number of partitions of 9 whose parts are 1 or 2 or 3. And I'll show you how to do that. We have, well, it's the coefficient of x to the 9, so we'll go back to the power series format, and we need the coefficient of x to the 9 in the series that looks like this, times this one, times this one. But something interesting happens here. We can ignore the first one, just for a little bit. It's still going to be there. In fact, I'd better write it out so I don't forget. But we're just going to multiply out these other two. Now, for the constants, the only constant we have is 1 times 1, so we start with the 1. There's no way to get just a power of x. X squared, there's only one way, x squared times the 1. For x to the 3, there's only one way, x3 times the 1. For x4, the only way is x4 times 1. There's no way to get an x5. We can get an x6 by x6 times 1. So there's only one way to do that. No, wait, that doesn't feel right. x6 times 1, x3, there's no x3. Have I done something wrong? Oh, of course, there's an x6 in here as well. So there are two x6. Oh, and this color is terrible, so let's fix that. Fix both those things. We've got an x6 in here, so we can have an x6 times 6. So there's two ways to get x to the 6. There's no way to get x to the 7. We can get x8 from 6 and 2. Or is there another way? 6 and 2. There's no 8 in here. There isn't a 3 and a 5. Oh, I know. I'm missing an x to the 7 because x4 and x3 would make x to the 7. So which ones can we use to get an x to the 8th? There's a 6 here and a 2 here, so that's one of them. A 3 here, but no 5 to go with it. A 1 here and an 8 here. So two ways of getting x to the 8. You'll get the hang of this and it'll come much quicker. presumably I'll get the hang of it too. And x9 we can get through the x9 in the second bracket times 1, or x6 in the first bracket and x3 in the others, so there's 2 x9s. And we only have to worry about those terms. Now, the reason we only need to multiply those second two brackets is we're looking for the coefficient of x to the 9, but look what's going to happen when we do the multiplication. We're going to have x to the 9 multiplied by, so 2x to the 9 is going to get multiplied by 1, and 2x to the 8 is going to get multiplied by x to make an x to the 9. And x to the 7 is going to get multiplied by x squared to make x to the 9, etc., etc., etc. 2x6 by x3. So rather than going through the error-prone exercise of multiplying out all three of these, you can see how many mistakes I made just trying to multiply out two of them. Instead of multiplying them all out, we can just take the coefficients that we've got so far and know that there's going to be exactly one way that each of those gets turned into an x9. So the total number of partitions is 1 plus 1 plus 1 plus 1 plus 2x to the 6th plus 1x to the 7th plus 2x to the 8th plus 2x to the 9, which gives a total of 12, which happens to be the correct answer. Part C looks complicated, but we can tack this on here because that was part B. Part C, when you want two distinct parts, the quickest way to do this is to say, well, we've got 12 in total, and then we want to subtract the ones that don't have two distinct parts. So the ones that are all 1, which is the 1 to the 6, the ones that are all 2, of which there are none, and the ones that are all 3, which is 3 to the 3. So there are only 2 of them that don't have distinct parts, so 12 minus 2 is 10, and that's our final answer for part C.